Okay, hi Keystone Chemistry students. This is a short little video to help with the frequently asked questions on the Density Lab. So, this video will show you the scoring guide, how to use the lab instruments. We'll talk about the lab report and identifying the material the cubes are made out of. So, getting started. The scoring guide. All of the scoring guides for your chemistry course can be found underneath the orientation tab. So if we go to the orientation tab and we go to this link right here, Chemistry with Lab Scoring Guides, this opens up the file with our Density Lab scoring guide. So on the pre-lab, I want a meaningful purpose that correlates with the procedure included. The procedure is in the lab room, and I will show you where that is. A thoughtful hypothesis is included for both parts, for Experiment 1 and Experiment 2. And an explanation of the experimental design. So what I want you to do there is tell me what steps are you going to take to complete the lab. This would be your procedure. For the lab work, for part 1 and part 2, so I need you to fill in the data tables. I need you to identify blocks using your density that you will be calculating. And data analysis. That means I want to see all of your density calculations. I want to see all of your math always for this entire course. Always show your calculations. And I want you to show me a percent error calculation. And what a percent error calculation tells us is how far off of a standard value we are. Say I am doing percent error calculations for a machine that fills egg cartons that are a dozen. And I calculate that every carton it is supposed to have, my theoretical value is 12, but in all in my egg truck I'm only getting 10 eggs. Well, my percent error would be telling me how far off from my actual value my egg company output is. And there are instructions on how to do that. There's a video in the lab. Your lab work needs to have a written conclusion, and they have to relate to your hypothesis statement. It doesn't have to support your hypothesis statement, just relate your conclusion to your hypothesis. In your post-lab, I want to see correct answers. I want to see all your math, and I want to, you will get, the correct answers are worth 3 points each, and you get 1 point for at least attempting. So to your scoring guide, your pre-lab is worth 20 points. The lab work is worth most of your lab, the 20 points. And your post-lab is worth 18 points. And if you go to this document, you can scroll down and you see what I use to grade all of the assignments for the entire course. And up here you can download it. So, moving on to the Density Lab. I'm going to enter my virtual lab. My objectives. I should be able to convert measurements relevant to my lab procedures, and calculations may also require some conversions, and I will flag some of those for you. You will become familiar with the relationship between volume and mass. You will be able to list the chemical properties of a substance, and you will be able to determine the densities of items using the density formula. Okay, here's a completion checklist. The lab report form I need to download. Purpose and hypothesis. So this is going to ask you to read through the lab report, and after reading through the lab instructions, fill out your purpose. Chemistry math. Here is a video to help you with the formulas. I'm not going to show it to you now. You can watch it on your own time. But here's the important part, entering the lab. So here's some information about density. There's also a lab equipment manual. So if during the lab, instead of coming back and watching this video, you could pull up the lab equipment manual, and that will help you in the lab. Okay, let's go to the lab. How do we start? Well, your instructions are all down here at the bottom, and there's a scroll button so you can scroll down, and there are multiple steps that you need to do. Remember, you need to outline that in the procedure section of your experimental design. Okay, when I am using the balance, I need to click on this little rectangle that opens the doors. The cube goes, I believe, on the right side, yes, and then I need to put combinations of weights on the balance. So sometimes one weight, sometimes two. I'm going to try my 1 gram and my 2 grams, so I have a total of 3 grams. I'm closing the doors, and you click on the knob, and that makes the balance do its measuring. Well, I want my needle to be centered on the 10. It is way off the 10, and that tells me that this side right here is too light. So I need to add a lot more weight to this side to get the actual value, the actual mass of this blue cube. So there are little pop-up instructions. This says click the turning knob to stop weighing, and then I open my doors again, and I would manipulate my weights and continue to do that until I got the mass of the blue cube. That is the mass. Now I need to find the volume. To find the volume, I put my cube in the water. Oh, I gotta thread tie the cube. Okay, now I need to put it in the water. Okay, this is the amount of water that was displaced when I dropped my cube in the water. So I got how many milliliters? Remember, we always read from the bottom of the meniscus. So I got 1 milliliter, 2 milliliters. And the trick to doing this lab is you need to remember that 1 milliliter of water is equal to 1 cubic centimeter of water. So this cube is actually 2 cubic centimeters in volume. So go through and complete all the steps. I'm not doing the lab for you. I'm just showing you how to use the materials. Take your cube out, and let's look at experiment 2. For experiment 2, we have a cube and a digital balance. To weigh the cube in this experiment, we put a cube on the scale. Now, measuring the cube is where a lot of kids have issue, because the vernier caliper is something very different that you may not have used before in life. So we drag our caliper over and we put it on the cube, and you get this little window that pops up. Now I'm going to show you how to read a vernier caliper. So here's our vernier caliper. This is a big zoom in that I have made so we can practice reading. So here is my bottom scale right here that I'm waving around, and here is our top part of the scale. Our top part of the scale gives us our first 2 decimals. The bottom part of the scale helps us get that 3rd decimal. And we actually need the bottom scale to tell us where that first decimal point is. So I am going to just randomly drag this here and stop this vernier caliper at this measurement. So this measurement would be 1 point. My first decimal place is wherever this lands. So this bottom mark in my caliper scale, the bottom scale, the mark lands between the 3 and the 4. So this would be 1.3. 1, 2, 3. 1.3. But it's not completely 1.4. It's somewhere between 1.3 and 1.4. Well, what's my next decimal place? What I look for in that is I look at these bottom lines in reference to the top lines. One of these sets, bottom and top, will line up almost perfectly. And I see that this one right here lines up so it looks like it's almost a completely, well, so it is a completely perfect straight line. that is your second decimal place. Well, what is that decimal place? That decimal place would be whatever this is on the bottom scale. So this line on the bottom scale is our second decimal. So that's 1.3, 1.31, 1.32, 1.33, 1.34. That is how we read the vernier caliper. Now let's do another measurement. So we would write the 1.34 down on our lab sheet, and then you would go on and measure your next cube. But we're going to practice making 2 more readings. So I'm going to stop this here. Okay, this cube would be 2. 2 point what? 2.1, and which one lines up perfect? None of them line up perfect. Well, I can't read this, so I have to reposition my scale. Sorry about that, kids. Why couldn't I read it? Because none of my lines lined up perfectly. None of them were a perfectly straight line. So I will reposition it here. So this one is this pretend cube that we have just made up is 1 point, that's the 1.5, 1.6. This is 1.7, and it's just a little bit over 1.7. So where do our lines line up just right? It looks like this one lines up just right. So we said it was 1.7. That would be 1.71, 1.72, 1.73, 1.74. So we would write 1.74 down. I'm going to do one more. And I'm just actually dragging this along and dropping it somewhere. Okay, so this one, this imaginary cube that we're measuring, well, our first line on the bottom scale lines up not even with the 1. It's before the 1. This is the 0.9 mark, so it hasn't made it to the 0.9 yet. So our cube would be 0.8 something. 0.8 what? Well, now we need to look at our bottom scale and see which one of these lines lines up perfectly with the top. So I would say that this one lines up perfectly. So our measurement would be 0.8, not 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8. That is the line that lines up perfect. 8.8. Okay, so that is how you use the vernier caliper. Now let's go back to our lab report. Okay, that is all you need to do with that. Now in our lab report, some questions that I frequently get. In your data table, yes, I need you to use the graduated cylinder and find the average volume. Then you are going to do some density calculations. So remember, your volume in cubic centimeters is actually exactly the same as in milliliters. So say you got 2 milliliters displaced, that will be 2 cubic centimeters. If you have 5 milliliters displaced, that's 5 cubic centimeters. So use your calculation, your formula right here, mass divided by volume, and then you're going to have a number right here. Well, what these numbers right here in the density column, you're going to look down here and see what cube corresponds with these densities. Now you should have numbers that are pretty close. If not, you have probably done something wrong in your calculations. So go back and remeasure, recalculate. Anyway, one of the cubes will be around 7.8, and when that calculated density is near 7.8, in that line you would tell me the element, I don't know which one it is, tell me which one of these elements is iron, which one of the cubes is iron, copper, and which one is zinc. For experiment 2, you take average masses with the digital balance, and you take 5 averages with the vernier caliper. And in science, we always use averages, or we very often use averages. In actual scientific experiments, they use averages. For the sake of time and learning environments, we don't always use averages because we don't have time to run experiments multiple times. So here you're going to do your measurements. Again, you're going to do your calculation just like last time. Then you tell me which density corresponds with the iron and copper and zinc standard accepted values. Tell me which cube is iron, which cube is copper, which cube is zinc. And there's a spot down here for you to write the calculated density because you probably will not get exactly perfectly 7.86 or 8.96. Then for your data analysis, this is where you show your calculations. You can type them in or you can print this page out, handwrite them, and scan it in. Either way. Your conclusions. Answer these questions that are up here. Your conclusion, I'm looking for more than just a few words. I'm looking for all of these questions to be answered very thoroughly. And your post-lab questions. A few little hints for the post-lab questions. Here are the substance densities that are standard densities if you were to look them up online. This up here should say substance density and have a merged cell, D-E-N-S-I-T-Y. The word just got split. I don't know why. Now down here, in question 3, be very careful with details. This talks about kilograms. And what is our table using? Grams. So you will have to do a conversion there. If you don't know how to do the conversion, go back and look in your text or do a Google search of how to convert grams to kilograms. And that looks like the only problem that you might encounter conversion-wise there. But again, please make sure you answer the questions thoroughly, show me your calculations, and don't skimp on your answers. 1 or 2 words won't cut it. If you have any more questions, feel free to contact me. Thank you.